Okay, so we want to talk about word problems. And so I'm showing you one of the ways of approaching word problems. But before we get into that, I want to talk about one of the major issues that I most commonly see, and kind of, I guess, it's the thing that bothers me is keywords. Okay? Oh, you just need to know the special keywords, and that will help solve all your word problem issues. That is total bull. Incorrect, wrong, every way, okay? And I will die on this hill, because knowing words can help get you started, but they are not the entire plan, okay? And that's why knowing more about it and teaching that more general idea is going to be a key thing. So that's why I like the ones that you're going to see today. So we have this one here, okay, cubes, and it's a nice general approach. And we got another one I'll be sharing with you, okay. So this first one, circling key numbers that we need to do, okay. So understanding what all those parts are. I'd even take that a little bit farther with what are the key units, because sometimes the units are what are going to cause students the biggest issue. Because, okay, yeah, these are similar numbers, but the units are different. How does that relate to each other? Okay, so the key numbers, including their units, okay. Then as you look, underline the question, okay. What is our actual end goal in here? And this kind of goes back to the how to solve it, understanding the problem. When I fully understand the problem, then I understand the question, formulate the plan for being able to do that, and what all information I have or I might be getting and needing, okay? So keeping that in mind, okay? Now, boxing any math action words and writing their operation sign. And they have the addition, subtraction, division, multiplication. Don't forget, there are actually 6 basic operations that you're going to need to be aware of. That's going to include exponents and roots, okay? And so exponents and roots are pretty important ones to include and keep in mind, because otherwise these really have a limit on how long you can use them. And that's something to keep in mind. You want to give them a strategy that will last more than just your class, more than just this week, okay? Now, there are actually 8 operations, but you can do that, and say operation and their sign, as you write this out, writing out the operation, you'll just continue to add in the other operations depending on what level you're at. Okay, so saying today we're only working with addition and subtraction, not even worrying about the division and multiplication, that's okay to do, but always saying, and there will be more later. Okay, so that way when we do add in more later, it doesn't terrify the students. Okay, eliminating any unnecessary information, evaluate and draw. Okay, sometimes that visual aspect is key thing. Drawing also includes like graphing. Sometimes that's part of the answer, or a methodology for getting your answer, okay? So making sure that this is kind of an introductory and you're going to add on to it, but if you continue to use the cubes method, right, you could introduce this in kindergarten and then continue to add to it and say, now this part is a little bit more, this part is a little bit more, okay? Then we solve and check, showing your work, okay? In those aspects, and check, okay? Do we see Polya's problem-solving methodology in here, okay? Understanding the problem. The first couple of lines here, the numbers underlining the question, are all about understanding the problem and understanding what I have in this problem to work with, okay? Then even the boxing of the actions and such like that. Okay. Now these action words are key. There are 4 phrases that indicate an end result of an operation. Okay. And those 4 are sum, that is the answer to a addition problem. to an addition problem. Difference, the answer to subtraction. Product, answer to multiplication. And quotient, okay? And that's the answer to division. Now, just because these words get used does not mean I'm doing that operation. If I say quotient, that doesn't mean I'm doing division to solve it. That means that there's division action going on somewhere in my problem. Now, if that some number divided by 5 has the quotient of 7, okay, am I actually going to do any division? Okay, I throw in that key word quotient, but the actual operation that the students do to solve is multiplication. They're going to do 5 times by 7 to get what my sum number was, or x, or however you want to phrase that. Okay, so remembering that these key terms are indications of an action that happens, not the action I'm doing. Okay, so really talking about that math action. Okay, that's what's happening in an equation, but not what I may be doing to solve the equation. Okay, and students get a big hang up there and say, oh, it says quotient, that means I have to divide. No, that means division is happening, not that you are the one doing the division. Okay, so little things like that that really hold up students. Okay, anytime that we use some of those key words, then students are going to get caught up. Now, an introduction saying these key words indicate, okay, actions that are happening, yes, absolutely, but they don't tell me what I'm supposed to do. I need to be a bigger problem solver than just recognizing key words. Because more often than not, life does not give you key words to let you know. You can't walk back into your boss and say, I didn't see any of the key words in this problem. I'm not sure how to approach this. Fired, you're out, you're gone. Okay? So making sure that we aren't putting some kind of limitation like that on our students. Don't do that to them. Okay? Now, I told you I was going to show you another one. Here's another nice setup. Okay? Just conquer the problem. Here we've got Polya's 4-step pattern, but mixed in, right? Okay? So, plan, solve, and check. Sounds vaguely familiar, right? That solving is carrying out your plan, checking, going back and looking at it. The plan, okay, being able to do this because you may pick some other general aspect for your problem-solving methodology on word problems. But the key aspects are the same, okay? Read, fully understand, reread, code, sketch, and predict, right? So this is where I'm going to use that visual aspect. This one hits it up sooner, right? And there may be certain problems where you want that visual aspect sooner in your problem to help you in answering it, okay? And I like this one because it asks a couple of questions. What is the problem actually asking you to do? Because you as a teacher are going to ask these questions of your students all the time. If you can give them something like this and say, okay, you ask this question of yourself. The second question is huge. What is a reasonable answer? Okay? The context of a word problem is the majority of the problem. Okay? It really is. Okay? So it tells you what kind of units you're going to have as your answer, what units it needs to be in or how you're going to transfer. Then the general size. This especially when I think back about multiplying decimals, okay? If I do some quick rounding off to the whole numbers, I have an idea of where that number should be, okay? And so then the decimal placement only makes sense in certain places. Okay? If it's 10 times too big or 10 times too small, it's not a reasonable answer, okay? And so when you're creating your own word problems, always make sure that you're getting reasonable answers, okay? Because that's really the skill we're trying to build, is that they can decode real-world situations into the mathematics, process that, and get a realistic answer, okay? So what are the strategies in showing their thinking? Okay, I really like each of these because sometimes you're focused on a specific strategy. but sometimes that's what makes the big difference, is how they're approaching it and what they're thinking about it, okay? So being able to see that, showing the thinking, that's why I'm showing my work, and you can find little errors. They may have the strategies and overall thinking in place, but when they show their work, I'm like, oh, caught that, fixed it now, okay? The questions that get asked here, okay, are they effective and efficient, right? Efficient is a key thing because sometimes you want it to be more efficient than what it is. I can get from one room to another by pounding a hole through the wall, or I could walk through the doors like a normal person, right? We're trying to teach them to walk through doors. It may not be the most direct route, but it's going to take a lot less work in the end than pounding the hole through the wall, okay? So is there another way to solve it? And is there a simpler way to solve it? Sometimes there's not, okay? Sometimes there's just one way, or you don't want them to explore a second way yet. We want to master, methodology 1 before we're going to move on to methodology 2, okay? And so today is all about making sure that we can do that. And then tomorrow we're going to master methodology 2, and then you can pick between the two of them. Okay, so sometimes, yeah, you do put the little limiters on them and say, this is to help you out. It's not to limit you forever. It's to make sure that you can master this thing. And being square with students about that. That's why we're doing that. Yes, there is another methodology, and we'll get there, okay? Or maybe you're not even going to teach that. That's something you'll learn in another class, okay? That you can do these in a simpler, faster way. Okay, but you don't have all the skills yet. We want to appreciate what we've got right here, right now in front of us. Okay. Now, also just going back and thinking about the check aspect. Okay, checking your work. Okay, did you actually answer the question being asked? Okay, and this one, the answer in a complete sentence. Yes and no. Sometimes we want a complete sentence. Sometimes we want just the numbers. It's not that big of a deal. But if there's a context to it, then I better provide that answer in the context that I'm asking about. If I want to know what is the price of rice in China, okay, and I say 2.5 what? It's the price of rice in China is 2.5 yen per pound. Now the context and all the units make a lot more sense for us, okay? So being able to actually fully answer that, and then look, does my answer make sense? These two questions connect to each other. Here I'm looking forward and saying what will be a reasonable answer so I can identify it when it comes up, and I go and ask, does that answer make sense in this context, or does it make sense in general for this kind of a problem? Okay? Should all of these be nice numbers and I don't have to worry about it, or are they sometimes going to be decimals or fractions? What form does it want to be in? Okay? So those kinds of aspects are really important. So here's just, two more general ways to approach that, because those common phrases aren't going to always last forever. So make sure that you're going to use that as much as possible. Because yeah, sometimes we're going to focus in on a formula to do something, okay? To be able to accomplish a specific thing. And that's good to know what those formulas are. So that way, as I read a problem, I automatically connect with a formula, okay? That's going to be my strategy. So as I fully understand that problem, it's going to give me my methodology and my plan. Okay? And then realizing just when those words, certain words do indicate certain operations and actions that are going to happen in this problem. Making sure that our students can make those connections is really the key thing, rather than saying, this tells me what to do. Tells me about the problem, and then you choose your own pathway for solving the problem.